review sheet. And obviously there's some set of questions associated with it. That bigger set that's been online for about a week and a half, that should be plenty of practice. But yeah, let me go over some of the logistics first, and then we'll dive in, okay? So everything is going to be done on Respondus. So you probably already had some experience working with Respondus in your previous classes. Same situation here. Let me go over to the other computer and let me go over that sheet. Maybe that's probably better. Okay, so let me go over here. Let me share this screen right here. Okay, so this sheet basically lays out what we've covered since exam 1. So that's about 5 weeks of material. Exponential distributions, Poisson process, and the CTMC, right? All of those are connected anyway. So those are the main topics. Everything will be done to Respondus. You're allowed to use a calculator. Obviously, no laptops for the calculation purposes, and no tablets, none of that. You should just use your laptop computer because you do need your webcam and your microphone. You're allowed 1 page of notes, both sides. You can write whatever you want. You also should have, I mean, I don't know how you would do the exam without this. Like, just bring in empty sheets of paper, a few empty sheets of paper, lay it down on the workstation that you're going to work on. And then when you go through that check, you just have to show your desk and make sure there's no issues, right? And then everything else is closed. No internet, none of that. Like, obviously, other than the exam itself, you should be. It's basically you're replicating the exact same test you would have taken in class. You're just doing it remotely. Just think of it as I'm in this room. I'm in the exam room, except I'm just by myself, right? So just treat it that way. Okay. How many guys, did any of you guys already try out the trial test on Respondus?
Not yet.
Okay, so I'm gonna just warn you right now, like you should go and try out that trial test on Respondus. If you're not successful doing that now, we're not gonna be able to, so if you email me on Wednesday and tell me I can't get in the exam because of X, Y, and Z reasons, it's because you haven't tried it out on your own. That's completely on you. I don't have the time or the resources to kind of fix that on the spot. So you need to go try that out. It won't take too long. Just go and try out. You have to use the Respondus browser and see if you can access the trial exam. Okay. I can tell when people have accessed it and tried it out. So, if you tried it out and something happens on Wednesday, that's, it could happen. But if you've never tried it out and something happens on Wednesday, that's completely on you. Okay. There's a whole reason why I set these things up. There's a reason why I set all of these instructions out. So it's your responsibility to read them carefully and understand what's going on. Okay. I apologize for formatting on the email over the weekend. I don't know why Blackboard just changes the bullet formatting for some reason. So it might have looked a little bit weird, but I'll try to use Gmail directly next time. But yeah, when I send emails to Blackboard, sometimes they screw up the formatting. Also during the exam, you can have there's a PDF file that attached with that email, the 1-page instructions basically summarizing what you need to do during and after the exam. It's there. After the exam, this is after it's all been closed, right? You need to take a picture of all the pages that you used in your exam and turn it in like you did at homework. Use a regular web browser like Chrome or Firefox, go on Blackboard and turn in the pages that you use for the exam. So one limitation here is that it's hard for me to give you partial credit if I don't know what you did, right? So you need to put in your final answer on Respondus. Okay, just type in the answer. But often case if you don't get those right, I still want to give you partial credit, right? So write out all your answers, like write out your work in those empty pages of sheets of paper, and write it out like 1A, B, C, number 2, A, B, and C, etc. So I can go back and give you whatever partial credit I can give you, okay? And that's the supporting document I'm going to look at when I'm grading your exam, okay? So make sure you turn that in on Blackboard. This is after the exam has expired. You have about 15 minutes to take all the pictures and then submit everything through the regular Blackboard link, not Respondus. The regular Blackboard link. It'll be under the exam folder. It'll be in there. Okay? Make sure you do that.
So we upload anything that we write on as well as our cheat sheet.
Yeah.
Okay.
Anything that was on your desk, basically, that you want me to look at, and if I can't make out what you're writing, though, I can't give you any credit either. So make sure it's legible, and so that I can give you, it's so that I can maximize your points. Okay, so I can't work off of nothing, right? So, yeah, just like you would do in homework, except this one's probably a little bit more messier, maybe, because you just probably writing down as much as you can, but. Yeah, just organize it the way you do in a regular assignment. All right.
Okay.
Yeah. Does that make sense to everybody else? Yep. Okay.
Good.
Yep. Yeah, and then what this? I know it's gonna be challenging, but we'll do the best we can on this. Okay. So hopefully my email over the weekend. I hate writing long emails, but I had to. So hopefully all of those instructions make sense. All of those steps, I try to break it down. So hopefully all of that makes sense. Remember, you can print out that one-page PDF file attached to that email during the exam. You can have that on your desk so that you don't forget what you need to do during and after the exam. Okay, that's okay as well. All right. If nothing else, I'm going to jump to the questions. Any other logistical questions about the exam?
I just want to comment, Professor, the reason why a lot of us probably didn't see it, sorry for that, but we had an exam today and then like the 13 other things, but now we're focusing on it, so we'll take care of it, don't worry.
Oh, it's fine. It's fine. I haven't checked who's looked at it or not. I just want to make sure you guys try that trial test on Blackboard at least before Wednesday. So if there's any issues, I can go and diagnose it.
Excellent.
Right? Yeah. No, I haven't checked anything. I'm sure you guys. I have a life too, so a little bit of life left. So you guys are busy too. So I completely understand. But make sure you do try it. Okay.
Dr. Kim, I have a question as well.
Yeah.
How do we go about asking questions in the middle of the exam?
All right, very good question. I'm going to do my best so that you won't have any questions, but this is how it's going to work. And I'm not sure if I can do anything about this. So I set it up so that you can actually leave Respondus if you have to, okay? You leave Respondus, and I'll be on Zoom the whole time, right, using our regular class link. So you can come on Zoom and ask any questions if you have to. But the timer is still going while you're doing that. So there's nothing I can do about the time. It's going to just keep going. So you would have to leave and come to Zoom, and then you would have to go back to Respondus. I'm pretty sure I don't know if Respondus actually saves your responses, though. That's the thing. You might have to re-enter any answers that you've already provided, which is not a big deal. If you have the work in front of you, just write down the answer at the end. Yeah. But that's the only downside. But I don't really see any other way that you'll be able to connect with me face to face. So right. I'll be on Zoom the whole time. Like while you're taking the exam, I'll be on it, hopefully by myself the whole time.
Sounds good. Thank you.
Okay. Does everyone understand? Yeah. It's a good game. Hopefully you won't need it, but yeah, in case, yeah, you have that call a friend option. Okay. All right. Any other questions? Logistical questions? Nope. Okay. Then I'm gonna jump to the review questions. More than likely, we're not gonna be able to do all of it, but I mean, obviously, I'll post the answers, and I'll post this PowerPoint slide as well. Let's start with this set of questions. These set of questions. X1, X2, and X3 are exponential random variables, all IID, so independent identical distributed. All that means is that they're all exponential, but they have different lambda values, right? Probability, I want to compute the probability that X1 is less than X2 is less than X3. So A, probability X1 less than X2 less than X3. Okay. So there's multiple ways to solve this. I'm gonna simplify this a little bit to make it easier on myself. I'm gonna split it into a conditional probability statement. So I'm gonna call this as probability that X2 is less than X3, given that the minimum of all, I'll just call it Xi, X1, X2, X3. The minimum of all three is X1 times the probability that the minimum of 3 is equal to X1. Let's just say a 1 and a 1. Does everyone see that the statement on the left matches the statement on the right? Are they basically the equivalent statements? What I wrote on the left-hand side of the equal sign and when I wrote down on the right-hand side of the equal sign, are they the same? They're the same, right? They're exactly the same, except the one on the right-hand side is easier to deal with. Okay. All right, so then I'm gonna
Okay.
say it again.
Is it easier just because we added conditions?
Yeah, I mean, I probably, if I have to do the left-hand side on its own, that's gonna be, well, I mean, I guess that's not too bad either, but the right-hand side is easier because it's easier to break it down, right? It's easier to break it down as those two parts, right?
Yeah.
So let's start with, let me start with this, let me use a different color here. I'm gonna start with 1, okay? This part right here. Okay, so what is this probability equal to? This is like asking probability, if I write the whole thing out, it's the probability of minimum of x1, since we have 3 of them.
Lambda
Okay,
1 over,
go ahead.
it was lambda 1 over the summation of all of them.
Yeah, exactly. That's the answer. Okay, that's that part. Yeah, if there was lambda 1, if there was 4 of them, it'll be lambda 1 over lambda 1 plus lambda 2 plus lambda 3 plus lambda 4. What if the minimum was not x1, but let's say it was x3 instead? What would this be
Lambda
equal
3
to?
over all of them.
Yeah, lambda 3 over the sum of the rest, right? Yeah, exactly, right? And then the second part, this part right here, given that the condition is true, what's the probability that x2 is less than x3?
Lambda 2 over lambda 2 plus lambda 3.
Yeah, that's the answer, right? And then this times what I just found, lambda 1 over lambda 1 plus lambda 2 plus lambda 3. That's the answer, okay? So one-liner, right? Great, that took was a lot faster than the last section, though. That's good sign. It's a very good sign. Part B, any questions on part A? No, okay, part B. Probability x1 is less than x2 given that the maximum is of x, let's call it xi again, because I don't want to keep writing all 3 of them down. Okay. So this question, again, there's multiple ways to do it. I'm going to try to simplify it for myself by using what I've already learned. Okay, so don't forget what you've already learned. So this is a conditional probability statement, right? So probability of A given B, I could rewrite as probability of A and B divided by the probability of B. Just a conditional probability statement, right? Okay, so then if I rewrite this, it'll be the probability of x1 less than x2 and the B part, which is the maximum of x3, is just basically saying this, right? Okay, divided by the probability of max xi equals to x3. Okay, I'm just using the definition of a conditional probability statement, okay, to get the numerator and the denominator. Any questions on what I just did? How I got that, those two expressions, numerator and the denominator. All right, so as soon as I did that, what do you recognize right away about the numerator?
We already found it on the previous problem.
Yes, we already found the previous problem, so let's not reinvent the wheel, right? This is from part A. Okay, so then just we're left with this part, right? So probability of max xi equals x3. Okay, so how do I get that portion?
The max.
I can take and do an integration and make it really hard on myself,
Max.
and you can get it done. Except I would just kind of think logically and try to break down the cases here. There's in which cases is an x3 the maximum, right? Then one case might be is this case, right? x3 is a maximum if this happens, right?
Yeah.
What's another case?
X2 is, well, X2 is less than X1 is less than X3.
Are there any other cases?
Negative.
Nope, that's all you need, right? Now, what do you also then recognize about this first part?
We already found it on the top.
First one.
Yeah, part A, right? And then how do we get this second part then?
1 minus the first part.
Not 1 minus. Good idea, but not 1 minus. Just look at part A though. I can kind of follow the same kind of pattern, right?
Mhm.
So yeah, so if I rewrite probability of x2 less than x1 less than x3, I'm going to copy basically what I did in part A, right? So this is going to be this is going to be x lambda 1 x1 less than x3, so lambda 1 over lambda 1 plus lambda 3 times the minimum, probably that the minimum of all three is x2, so it's lambda 2 over lambda 1 plus lambda plus 3. Okay, let me pause it right there, and then let me make sure everybody's on the same page here. This portion I got by basically doing this again, right? Except in this case, it's lambda x1 less than x3, given that the minimum is x2. So instead of having lambda 2, I have lambda 1, and it's lambda 1 plus lambda 3 at the bottom. That's how I got this part. The next part is the minimum being x2 this case, right? Okay, so it's lambda 2 over the rest. So that's how I got the second part of that denominator. Okay, so then we're ready to put all this together. We're ready to put all this together. So let me just write it down here, okay? I'll try to squeeze everything in there. So the answer is going to be, probably going to be, I'll try my best to squeeze it in there. Okay, so it's going to be lambda 2 over lambda 2 plus lambda 3 times lambda 1 over lambda 1 plus lambda 2 plus lambda 3. That's my numerator, divided by the same expressions, lambda 2 over lambda 2 plus lambda 3 times lambda 1 over lambda 1 plus lambda 2 plus lambda 3 plus what I just found, lambda 1 over lambda 1 plus lambda 3, lambda 2 over lambda 1 plus lambda 2 plus lambda 3. Okay, so that's the answer. So in the exam, unfortunately, because of the limitations we have, because this is virtual, I will give you lambda values for lambda 1, lambda 2, and lambda 3. If you had a question like this, and you just have to plug those values in and then type in your answer numerically. Okay. Now, if you get it wrong, then I can go back and look at your work and see whether it was just like a plug-in error. Then even if you get the answer wrong, but if you got this expression, you still get 100% in my view. Because I don't really care about the value. It's just the limitation we have because it's online now.
So
Does that
if
make sense?
numbers are plugged in, do we like have to, can we just keep it separated? So like if it's like 5 plus 3 plus 5, rather than making it like 13, we can just leave it at 5 plus 3 plus 5.
Sure, I think that's fine. I don't. That
Just so we
example,
can, yeah.
that example, I think you should just sum it up. But no, I see what you're saying. No, keep it. Yeah. So more limitation again, though. I don't know if Blackboard lets you input an answer like that, though.
Oh, okay.
They might just still expect a value. But
Okay.
yeah, don't worry too much because for me, if you get the expression correct, that's more important. So let's say you plugged in the values, it turned out to be wrong. But if I look at your work and the expression was correct, you're still gonna get 100% on that question.
Okay.
Yeah. But you need an answer there somewhere, right? So you got to
Yeah.
throw in a numerical answer somewhere, right? So that's the only limitation. In a real class exam, you could have just left it with just on the screen, and that would have been it, right? But here, Blackboard or respondents wants an answer, so you gotta. Unless you want to write out this equation as your answer, but no, that would be a nightmare. No, let's not do that. Yeah. Okay. Or I mean, very, very unlikely. It might be a multiple choice, right? Or like you have first options to select an answer. Like the polls we've done in class, it might be like that. Right? But more than likely, it'll just be values that you have to plug in. Okay.
Professor.
Yeah.
I have a question, but I'm not sure if it will, like, I have a different answer, but I think it's not the right answer. I mean, after looking at probability minimum x1, x2, x3 equal to x1, I found like a different answer for probability maximum xi equal to x3, which is going to be lambda 1 over lambda 1 plus lambda 2 plus lambda 3 then like we sum it up with lambda 2 over lambda 1 plus lambda 2 plus lambda 3.
So there's always multiple ways to do this. So you're right in the fact that there's probably other ways to do this. So what you can do is just make up a value for lambda 1, lambda 2, lambda 3. Just make it up, plug it in, and see if it matches the answer that you see on the screen.
Okay.
Then if they match, then how you did it would have been fine, right?
Okay.
Right. So I can't really check on the fly right now, right? So
Okay.
yeah, just make up some value. Make sure they're different values just to make sure. Like lambda 1, let's say is 5, lambda 2 is 6, and lambda 3 is 7. Plug it in and see if it matches the answer I would have gotten if I plugged in those values to the final answer I got. Yeah.
Gotcha.
Okay. Any other questions? No. All right. Let's go to part C then. This is a little bit simpler. Now we're looking for the expected time, right? Expected maximum time xi given x1 is less than x2 is less than x3. Okay. Multiple ways to kind of think about this problem. I'm gonna just assume I don't know what's going on here. I'm gonna just draw a number line. Okay. This is a time for x1 to happen, right? That's the value of x1. x2 is technically this right here, this long stretch, and x3 is this longer stretch right there, right? Okay. How long does it take for x1 to happen? What's the expected time for x1? I'm sorry, say that again?
Lambda 1.
1 over lambda 1. I think it's a little bit more.
It's plus lambda 2 plus lambda 3.
Yeah, it's all the lambdas combined, right?
Yeah.
It's
the minimum of them.
Yeah, it's minimum all 3, right? Okay. So this whole thing is 1 over lambda 1 plus lambda 2 plus lambda 3, right? And plus, so once you're here, let's go over here now. Okay. How long does it take for this to occur? I'll call this S2.
1 over lambda 2 plus lambda 3.
Yeah, so this is now saying minimum of x2 and x3. It's 1 over lambda 2 plus lambda 3.
What's that name, Professor, when it doesn't matter what happened in x1, now you only care about x2 and x3?
Memoryless?
There you go. Thank you.
Now that we're here, how long does this S3 take?
1 over lambda 3.
1 over lambda 3. That's your answer. This is my final answer. Yeah. This is a lot simpler because my condition helps me. Okay. Let me pause it right here. Any questions on this problem?
I think I had an issue seeing how it became that. This one seems harder for some reason.
Yeah, it's a lot simpler though, right?
Yeah.
So this condition, let me draw the highlight. Oops, wrong one.
So when it just says max, what is the map? We just want the max amount of time combining all of them.
Yeah. So this portion here, this condition, tells me x3 is the last one to go, right? It's the last one to finish, right? Okay. So the maximum xi is x3, right? I could have rewritten this as expected value of x3 given that x1 is less than x2 is less than x3. Yeah, I could have written it that way. It would have been the same statement here.
Okay, yeah, it's a notation I didn't understand. Thank you.
Yeah, this is like, what's the maximum xi? So whichever is maximum, what's the expected time of that one? But on the condition, it tells you which one it is. It's x3, right? But I would argue this problem. So I'll give you another example, right? If I were to change this problem, let's say instead of x1 is less than x2 is less than x3, I could have rewritten this as x2 is less than x3 is less than x1, right? Okay. Maximum xi given the x2 is less than x3 is less than x1, then my answer would still be 1 over lambda 1 plus lambda 2 plus lambda 3, okay? But x3, the second part, it would now be 1 over lambda 1 plus lambda 3, and it would be 1 over lambda 1 at the end. But this would have been the answer for the other case. Okay, so the reason why you write max xi is so that if I change that condition, it's still, I guess you can reuse that portion again, right? So the notation, yeah, I could have, so this one, red one, I could have written as expected value of x1 given what I just wrote down right there. Okay.
Thank you.
Yeah.
Dr. Kim,
Yeah.
is this the one where I forget what lecture it was, but it had what is the expected time for Peter and Brian and Stu to leave the bank? Is that the similar one?
I don't recall exactly, but all of those like type of questions are related. But I mean, I can't really tell you like this is an exact I can't tell you that this is exactly the same problem that you did in the lecture though. I don't. First of all, I don't remember exactly.
Mm.
My guess is it was probably a little bit different. Yeah, I'm not sure. They're all. I mean, I could change one assumption here and the problem changes, right?
Yeah,
So,
I remember it being very similar just because the one we had had like had an additional part where it told us like who left last and who left first. So in that case, we already know which lambdas to add to each other.
yeah. So the key here is that if I were to just ask you, let's say expected value of max I, this is a lot more harder problem versus what you were just given, right? As soon as I add a condition, right? Something like whatever, if I add anything, the problem actually becomes a lot easier once you have a condition. Okay. Let me pause here actually, and no, I'm pretty sure there's few people still who are going to struggle with this concept. Okay. What's the expected value of x1?
1 over lambda 1.
The one.
1 over lambda 1. 1 over lambda 1. What is the expected value of x1 given x1 is less than x2? Is this the same? Are these two the same?
No.
No, right?
You have to multiply the
It's-
probability that x1 is less than x2.
Yeah.
Yep. Which is
Well, that's not even multiply the probability. I mean, I'm saying, are these two expressions the same? So you just told me this is 1 over lambda 1, right?
yeah.
Is the left-hand side also 1 over lambda 1?
No.
No,
No,
it's
right?
1 over lambda 1 plus lambda 2.
Yeah. Right?
Mhm.
Okay. So this is a subtle, no, actually, this is a critical point. I'm sorry?
Oh, I'm sorry. Go ahead. Sorry.
This is a critical point, right? You have to understand this concept, right? Expected value of an exponential variable is 1 over lambda, but the expected value of an exponential function, given that it's less than some other exponential function, it changes the expression completely then, right? Okay, because once it's the minimum, that in itself is an exponential function with all the lambdas combined. Okay, so I think this is the one of the major. So like this question, when we say the maximum xi, given that x1 is less than x2 is less than x3, you might be tempted to say, okay, that's just 1 over lambda 1 plus 1 over lambda 2 plus 1 over lambda 3. This is completely wrong, right? Okay, because the fact that it's a minimum, it's not 1 over lambda 1, it's 1 over all the lambdas combined. The fact that x2 is less than x3, given that condition, it's 1 over lambda 2 plus lambda 3. And the last one, you're not comparing against any other one, so it's just 1 over lambda 3. Okay, so I want you to kind of understand that. I think is probably one of the main flaws, or one of the major conceptual things that a lot of students don't take the time to understand, and then you can't really solve these problems otherwise. Okay, so hopefully that's helpful for some of you who are struggling with this concept. Any questions? Nope. Okay, so I'm gonna go to number 2 then. Green men arrive at the launching pad according to a pulsar process rate mu equals to 2, while red men arrive according to a pulsar process with rate lambda equals 3. The spaceship leaves when there are 3 men of either color at the pad. What is the expected time required to fill the spaceship? What is the probability that the spaceship is all green? Okay. All right. So my advice in a question like this, number 1, don't panic when you read stuff like this. It seems a lot more complicated than it actually is. This, I would say, is like, this is all like one-liners. They're nothing about this is that. Okay. So another thing is, I don't know why some of you guys think this way, but I don't know where this comes from. I just don't care about like a lot of like my goal here is not to trick you or like to confuse you. My goal here is to make sure you're at a certain level, you know, that you understand it well enough so you could move on and be a competent person, right? So don't imagine stuff. I get really frustrated when you guys start imagining stuff in a problem that I've never intended. Like if you find yourself kind of confusing yourself or adding extra stuff in there, you're doing it to yourself. Like take a step back, take a deep breath, and simplify it. Whatever I ask you is not going to be a stretch from what you've already seen. As in, it might be more difficult, but it's reachable from what you already know. Okay, if you really understand what you've already learned, then it's reachable. Okay, so keep that in mind. Just calm your nerves that way, because otherwise, if you see a simple problem like this, you can go in circular. You can go in like circular, you know, whatever. You can go some random place and you won't come back. Okay, because this, okay, and for me when I have something like this, oftentimes it's just better sometimes to just draw a diagram, see if I understand this understand the situation. So this is my launching pad. Okay, that's my launching pad. I have green men arriving at a rate of 2. Let's say 2. It doesn't give you a rate, but it's gonna have a time unit, right? And then you have red men arriving at a rate of 3, right? Okay, you have 2 pulse-on processes happening at the same time. Okay, so you could have green, red, green, or red, red, green, right? It's any 3 combinations, right? So I want to know the expected time until the third person arrives. Okay, so I'm going to draw a little timeline here, starting from 0. This is when the first person arrives. That's the second. Let's say that's the third. Okay. How long does it take for that first person to arrive?
1 over lambda plus mu.
1 over lambda plus mu, right? First arrival. Okay. Right after the first arrival happens, how long does it take for that second arrival to happen?
Okay.
It's the same, right?
Yes.
Okay. And then the third arrival, how long does the third arrival take?
Same thing.
Same thing, exactly. That's your answer. Your answer is just 3 over lambda plus mu. If you plug in the values, 3 over 5. That's my answer. Okay. Part B. All right, any questions on that one?
Yes, actually, I have a question. So it's the expected time. So it's like it's 3/5. Like, I guess I kind of struggle with that, like 3/5, like minutes, like hours. Or is that just like the rate?
No, yeah, so this problem, I mean, if this were given in an actual exam, I would have to give you the units. So this should have said, for example, 3 per hour, let's say. Then this answer would then be hours, right?
Right. Okay.
Yeah. Does that answer your question?
Yes. Thank you.
Okay.
Dr. Kim,
Mm-hmm.
is it the same expression just because it's memoryless?
Yeah, I mean, you have 2 exponential processes happening at the same time.
Yeah.
The next event is it's like saying, you know, you have like the next event has to be the minimum of whichever, like however many exponential processes, right?
Yeah.
So it's the next event, the expected time until the next event is always 1 over lambda plus mu.
Yeah. Okay. Got it.
Yeah, let me pause it right there. Actually, ask this conceptual question then. I just had an arrival. Someone just arrived. Okay. What's the expected time until the next green arrival?
If
1
1
over
over
lambda plus
lambda plus.
Let me rephrase. What is the expected time until the next green?
1/5.
1/5. No.
If lambda is 3, it will be would it be 1 over
1 over mu.
1 over mu? Sorry.
1
Yeah.
over mu. It's just 1 over mu. Okay.
Yeah.
What is the expected time of next green given that the next arrival, green arrives before red? What is that equal to?
1 over lambda plus mu.
Yeah, so now this is 1 over lambda plus mu. Okay. again, same as what I said in the last problem, this concept is critical, right? The expected time until the next green, if you're not comparing with anything else, is 1 over mu. That's how long it takes for the next green arrival to occur, right? But the expected time of the next green arrival, given that the green arrival happens before the red arrival, is the minimum between those two now, so it's 1 over lambda plus mu, right? So that's a side note there. So hopefully that, again, helps some of you guys who are still kind of fuzzy about this concept. Hopefully that helps. Okay. Any questions? Nope. Okay. Part B. What is the probability that the crews are all green? So probability all crew are green. Okay. So again, I'm going to break this down. 0. Next first arrival. It's capacity of 3, right? So we have 3 people who need to arrive. Okay. What's the probability that my next arrival, next person is green? The probability that the next arrival is green.
Mu over lambda plus mu.
Mu over lambda plus mu. Okay. Given that's happened, what's the probability that the second person is also green?
Would that be same?
Same. Okay. Now that just happened now. What's the probability that the third person is also green?
Also the same.
It's the same, right? So it's the probability that all 3 green is mu over lambda plus mu cubed, right? 3 times in a row, right? It's like saying if I flip a coin, heads or tails, what's the probability I get heads in the next one? It's just, mu over lambda plus mu, right? Okay. What's the probability I get heads again? It's mu over lambda plus mu. What's the probability I get heads again? Mu over lambda plus mu, right? All 3 times, right? So then I plug all that in, it'll be 2 over 5 cubed. That's my answer. Okay. Any questions on this one? I think I asked this, I think this was an exam question a couple of years ago. Man, the amount of writing people did on this, it was supposed to be like a gimme, and I was just, it was sad because, yeah, it shouldn't have taken too long. But again, I think that's why I want to tell you guys, don't overcomplicate it, right? It's not going to be anything, I'm not going to pull something out of random place, right? It's going to be reasonable, right, from what you've already been taught, right? Okay. Okay. Number 3. A small barbershop operated by a single barber has room for at most 2 customers. Potential customers arrive at a post-time rate of 3 per hour. Successive service times are independent exponential random variables or mean 1/4 hour. So right away, I know lambda is 3 per hour. What is mu here? Or the service rate? You have people arriving at a barbershop. They
4
get
per hour.
2.
4 per hour? I heard 4. What was the other one?
Yeah, 4 per hour.
4 per hour, right? So I'll write it down. So it'll be 1 over 15 per minute, right? Because it tells you the mean is 1/4 of an hour or 15 minutes. Okay, so it'll be 1/15 per minute. If I convert that, it'll be 1 per hour. When you do these problems, lambda and mu have to be the same units. Okay, if they're not the same units, you're gonna go terribly wrong in terms of the final answer, right? So lambda and mu have to be the same units. Okay. Another reason why I tend to solve everything symbolically first is so that even if I make a mistake with these units, the answers don't change, right? If I solve it symbolically, right? I just have to change the inputs later. Okay. If I draw the rate diagram for this, it'll look something like this. Lambda 0, lambda 1, mu 1, mu 2. Okay. In my case here, lambda 0 equals to lambda 1 equals to lambda. It's just 3 per hour. Mu 1 equals to mu 2 equals to mu equals to 4 per hour. So if we have those, I'm going to just set up my system of equations. So this problem is a little bit longer. I'm going to look at state 0. Mu 1 times P1 has to equal lambda 0 P0. If I look at state 1, it'll be lambda 0 P0 plus mu 2 P2. So I'm looking at state 0. The states that are entering state 1 is P0 times lambda 0 plus mu 2 times P2, right? that has to equal mu1 plus lambda 1 p1. My final on the state 2, it's going to be lambda 1 p1 has to equal mu2 p2. And the last equation I need is p0 plus p1 plus p2 has to equal 1. Right, I have those four sets of equations, right? Part A, what is the average number of customers in the shop? So I actually still need to solve for P0, P1, and P2 to answer any of these questions. So I'm going to go and solve for P0 first. So I'm going to use this final equation to make it easier on myself. So I need an expression for P1. I'm going to use this one right here. P1 has to be lambda 0 over mu1 P0. If I need P2, it'll be P2 equals lambda 1 over mu2 P1, right? And I can then plug in P1 from the one above. So it'll be lambda 1 mu2 times lambda 0 divided by mu1 times P0. Since all lambdas or mu's are the same, these are just lambda over mu P0, and this will be lambda over mu squared P0, right? Okay, now I'm going to solve P0 plus P1, which is lambda over mu, P0 plus lambda over mu squared P0 has to equal 1. Then P0, 1 plus lambda over mu plus lambda over mu squared has to equal 1. P0 then has to be 1 plus lambda over mu plus lambda over mu, the whole quantity squared, inverted, right? Put this over here. 1 plus 3/4 plus 3/4 whole quantity, again inverted. This would be, ends up being 37 over 16 inverted. So then it's 16 over 37. Okay. What does that tell me? What does that P0 tell me?
Portion of time that the shop is empty.
Okay, proportion of time that the barbershop is empty. And then P2 would tell me the proportion of time that my barbershop is at capacity, or 2 people. And then P1 tells me the proportion of time I have 1 person in my shop, right? Okay, so if I want to find the average number of customers in the shop, then how do I find the value? How do I get part A? What's the average number of customers in the shop? If I'm at P1, how many customers are in the shop?
1.
1. If I'm at P2, how many customers are at the shop?
2.
2. If I'm at 0, there's 0, right? Okay. Then can't I just take the expected value and that'll tell me the average number of customers in the shop? The answer is yes, right? So, okay. So P0, for the sake of time, I'll kind of speed this up. P0 is 16 over 37. Then P1 is going to be 3/4 times 16 over 37. And then P2, excuse my writing, made 3/4 squared 16 over 37. So if I want the average, so this is part A, average number in system, it's simply going to be 0 times P0 plus 1 times P1 plus 2 times P2, right? It's like remember, like the expected value of X is a summation of Xj, probability of Xj, right? Same idea here. Okay. Okay, same idea here, right? Okay, that's what I'm doing down here. So P0, we know it's going to be 0, so just 0 plus P1, it's 3/4 16 over 37 plus P2 would be 2 times 3/4 squared 16 over 37. The whole thing then will be 30 over 37. So that's the average number of people in the shop, less than 1 on any given time. Okay. What is the proportion of potential customers that enter the shop? Okay, so this one, at which states is there? So when you're at capacity, we're assuming that nobody else enters, right? So then at which other states do you have people entering?
0 and 1.
0 and 1, right? So the answer then is P0 plus P1. Or you can say 1 minus P2. Either way, it's going to be the same answer, right? Okay, which is going to be 28 over 37. Okay, part C. If the barber could work twice as fast, how much more business would he do? What changes in this problem?
Is equal to 8.
Mu equals to 8
Lambda
now,
goes
right?
from 4 to 2.
Say that again, Gabe?
Does that mean that the lambda would go to 2?
No, the lambda is assumed is the same. Lambda is still 3. Okay, so if the barber could work twice as fast, that means just the service rate mu is changing. Lambda is our arrival rate. So the barber can't control like how quickly, how often customers come, but barber can control how fast he works, basically in this problem. Now you can argue that if he starts working fast, then there may be lambda will increase in the future, but for now we're assuming it stays constant. Okay, so then the only thing that changes is mu is now 8 per hour. Okay, then what do I need to do to answer this question? You have to go through this whole thing again. Yeah. So obviously this thing wasn't asked in a real exam. It's probably going to take too long to do part C. But you have to kind of, this is good practice though. You would have to do part A again. You'd have to solve for P0 and P1. Okay. Turns out when mu is 8, P0 is going to end up being 64 over 97. P1 ends up being, So it's going to be, when you do P0 plus P1, so that's the proportion of time when people are entering the barbershop, right? That ends up becoming 88 over 97. So this is, you can call it, so pre or initial, or I'll say initially. Okay, the rate of customers entering was lambda times 28 over 37 from part B, right, per hour. And then the new rate is going to be lambda times 88 over 97 per hour. So then the difference here is going to be lambda times 88 over 97 minus 28 of 37. If you plug in lambda here, you're going to get roughly 0.45 per hour. So if you assume this barber works 10 hours a day, then he's averaging 4.5 more customers per hour. If he works, let's say 100 more hours in a given month, he's averaging 45 more customers for that month. Okay, does that make sense, everybody?
Are you putting up this recording today to have
Yeah, I'll post it as soon as I can. Yeah, sure.
Okay, thank you.
Yep.
Yeah, you lost me after the system of equations.
Oh, okay. Yeah, so Adam and everybody else, like this. Oh, actually, no, it's not as easy on this one because you can't just do P matrix to infinity, right? In this one, yeah, you do actually have to solve the equations. Yeah, I mean, just, I would follow the same format, right? I would always use that last equation, P0, P1, P2 equals to 1. I would probably use that equation to solve for P0. I think that's the easiest roadmap. Okay. All right, any questions on this one? No questions. All right, we only have 5 minutes or 7 minutes, 6 minutes. I'm gonna skip number 4 because when you look at the solution for number 4, it's super easy. So number 4 is skip. Number 5, let's try this. This is a lot more interesting problem. So in a certain system, a customer must first be served by server 1 and then by server 2. The service times at server I are exponential with rate mu I equals to 1 or 2 for those two servers. On arrival, finding server 1 busy, waits in line for that server. Upon completion of service at server 1, a customer either enters service with server 2 if that customer is free, or else remains with server 1, blocking any other customer from entering service until server 2 is free. Customers depart the system after being served by server 2. Suppose that when you arrive, there's one customer in the system and that customer is being served by server 1. What is the expected total time you spend in the system? All right, so I'm going to draw a diagram here again to kind of understand what I'm dealing with here. I have two servers. Okay, so first you have to enter, get serviced at server 1, and then you walk over to server 2, get serviced at server 2, and then leave. When you walk in, there's already somebody at server 1, okay? And then you just walked in, okay? I want to know expected total time. Any ideas how you want to approach this problem?
Would that be the expected wait time plus the expected process time?
Yes, but I think you have to break it down even further, right? Because there's two servers. So if you break it down further, it'll be, I'll have two waiting times and two service times, right?
Yeah.
Okay. So the way, this is going to be very then similar to that homework question we had. So this is the expected wait at server 1 plus the expected service at server 1 plus expected wait at server 2 plus expected service at server 2. Okay, so far, everyone with me? I'm going to break it down into those 4 parts. Let's take care of the easier ones. What's the expected service time at S1?
mu1.
1 over mu1, right? What's the expected service time at server 2?
1 over mu2.
1 over mu2. Okay, if right when I get there, I have to wait, right, for this first person. How long do I have to wait?
1 over mu1.
1 over mu1. Okay, so really the only hard part is this part right here. Okay, I'll call that, no, just rewrite it. So expected, I'll call this expected time of WB. Okay, I'll call this W2, I'm sorry, W2. Okay, so then if I want to find the expected waiting time at server 2, I got a condition on 2 factors, right? Is there somebody there when I walk over? Is there nobody when I walk over, right? So I'm going to redraw this picture then.
Dr. Kim, the expected wait time at server 1, is it 1 over mu1 or 1 over mu2?
Mu1.
Oh,
You're right. Yeah, sorry, mu1. Yeah. Okay. All right. So expected waiting at server 2. The first case is I finish first at server 1, I walk over, and that person is still there, right? Okay. So that's the expected value of W2 given, I'll write it as S1 completes first, as in my S1 completes first, okay, and the probability of that happening. Okay. The other case is this person at server 2 finishes first and leaves, then when I walk over, there's nobody there, right? So that's expected at waiting at 2 given S2 completes first and the probability of S2 completes first. So this portion here, what does that equal to? If person at server 2 is done before I'm done at server 1 when I walk over, how long do I have to wait at server 2?
0. You don't have to wait at all.
Yeah, so this whole thing is 0. Then we're just left with this portion, right? Okay, what's the probability that I finish before the person at server 2?
mu1 over mu1 over mu2 plus mu2.
Yeah, right? So mu1 over mu1 plus mu2. What's the waiting time at server 2 then, if that happens?
1 over mu2.
1 over mu2. So that's my answer. Okay, so I'm going to put all of this together then. I don't want to write the whole thing out. So I'm going to call this 1. I'm going to call this 2. I'm going to call this whole thing 3. And then this last one is 4. So then the answer will be 1 plus 2 plus 3 plus 4. Do you guys want me to write that out, or do you get my notation here?
We get it. I get
Okay.
it.
All right, good. All right, so it's not too long. 1 over mu1 plus 1 over mu1 plus mu1 over mu2 times mu1 plus mu2 plus 1 over mu2. Okay, that's my answer. Okay, let me go over here. Oh. All right, you guys, you guys look beat. Yeah, rough week for you guys, huh? Yeah. Any questions on the review questions? Nope. Okay, so like I said, do your best. I don't know. I mean, I know this exam is probably, I don't think it's that bad, but I think for a lot of students, maybe it's just it basically really depends on your experience, but it might be tough for some of you, which is completely understandable. But look, I've done this many times, and I know what's doable and what's not. So you're capable of doing it. You just have to make sure you kind of push yourself and you get to a certain level. So, don't expect any less from yourself. That's the only thing I can tell you. Like, you're capable of doing this. So you got to kind of force yourself to kind of, get yourself up to that level. And just best of luck. I'll be available today and tomorrow. Make sure you do that trial run before Wednesday to diagnose any issues. And then, yeah, I mean, it will work out if I want you to leave with a certain level of competency. So, don't expect any less of yourself, right? Like, you can get it done. And I think a lot of students even surprise themselves on how well they can do this if they really, push themselves and apply themselves. So I'm gonna keep it as it is, and I just wish you the very best, and I'm here to support you. Okay. Any other questions, comments?
I've been rewatching the videos, and it just makes more sense after rewatching them. If that helps anybody else.
Good. Yeah.
Clarifying question: is the formula sheet we get, is it both sides or just one side?
Both sides.
Thank you.
Yeah. Anything else? Nope. Okay. And I also, one note on the, and you guys can leave anytime.